Hello and welcome to today's lesson, lesson 5.1, solving systems of two equations graphically. So we're going to be looking at systems of equations today and in this module, both equations and inequalities, and we're going to be solving them in many different ways, the first being graphically. So what is a system of two equations, or just a system of linear equations, or two linear equations? Remember, those are our lines with a set of number of solutions. Can be set equal to one another and solved, can be graphed, but we're looking for the solution. So there are three types of systems. There are those that have one solution, those that have zero solutions, and those that have infinite solutions. We're going to be looking at all those different types of graphs over the course of this module. So the first being parallel. So when graphed, because remember we're looking at graphically today, so when graphed, the lines will never intersect. Thus there are zero solutions. So parallel lines have no solutions. Coincident, or they coincide. When graphed, the lines overlap. They are the same line. Thus they have infinite solutions because they're on top of each other. Every point is on top of every other point, thus infinite solutions. They intersect. When graphed, the lines intersect at one point, the one solution. So the solution to a system of equations on a graph is the point where the two lines intersect. It's going to be very important. Most systems of equations have one. I would say almost close to 90% of the equations systems that we're going to look at have one solution. It's that point of intersection. We also have perpendicular lines. Remember, those are lines that form a 90-degree angle. They only have one solution, that point where they intersect, but they are more particular, more special than just intersecting because they do meet at a 90-degree angle. And there's something special about their slopes in that situation as well. So when I look at an example here, let's take a look at example 1, and I want to find the solution to this system. So the solution to this system of two linear equations is the point of intersection of the two lines. So I'm just looking, where do the two lines intersect? They intersect right at this point. Well, what are the coordinates of that point? Well, it's 1, 2, 3, so that's -3, and 1, 2, 3, -3. So my solution is -3, -3. It is that point, -3, -3. And that's it. That's the solution. So I just look for, where does my graph intersect? It intersects at the point -3, -3. It has one solution. It's -3, -3. That is the answer. It's not x equals -3 and y equals -3. It's just -3, -3. It's that point of intersection. So let's find the solution to this system. Once again, I'm just looking for that point of intersection. That is my solution. So it looks like they intersect right here at this point, which is at 2, -1. So my solution is 2, -1. So given a graph of system of equations, I'm just looking for the point where they intersect. Solve the following system by graphing. Okay, so now I'm given the system, but I need to graph them. So I'm going to need to remember some of the work that I've done in previous modules on how to graph linear equations, and I'm going to need to graph this. So let's start by looking at the first one, the first equation. So I'm going to just do this one in red, and I'll do this one in green, and then we'll look for that point of intersection. So let's look at the red line first. So y equals -x plus 4. So I start at 4. 1, 2, 3, 4. My first point, and my slope is -1, so down 1 over 1, down 1 over 1. So I have some points here. I'll do my best to draw a straight line. Remember, this is just a sketch. I could continue these points if I wanted to. I would hope you'd be using a ruler to make sure that you have your straight lines, because we really do want to be accurate here so that we know where our lines are going to intersect. And I'll graph the second equation, 2x plus 1. So I started the plus 1. 2x tells me rise 2, run 1. So up 2 over 1. Up 2 over 1. And I could connect those for my graph. And there's my line. So once again, I'm looking for the point of intersection. It looks like they intersect right there. So solving the system of equations means I'm looking for that point of intersection. Where is that point at? Well, it's at 1, comma 3. So what's my solution to this system? I have solved it. There's one solution. It is at 1, comma 3 by graphing it. Let's look at another one of those where I can solve this system by graphing. And why don't you try this one on your own? So please pause at this time, try it on your own, find the solution, and we'll check in just a moment. Okay, hopefully you've had enough time to try it on your own. So once again, I'm going to use two different colors. I'll do the first line in blue, and I'll do the second one in red, and I'll graph my two equations. So I'm going to start with my blue line, negative 3x plus 5, so plus 5, 1, 2, 3, 4, 5, down 3, over 1, down 3, 1, 2, 3, over 1. So I'm kind of graphing my slope here. 1. I can connect my dots. I want to do the best I can. It's really about these points, though. It's really what I'm interested in. I would be using my ruler. And I'm going to graph this one. So I start at negative 7. 1, 2, 3, 4, 5, 6, 7. And I'm just going to go up 1 and over 1. Kind of see where this is already heading. So at this point, do I even need to continue graphing? Do I even need to graph the line? No, I see that point of intersection right there. If I was going to graph this line, it would look like that. So they intersect right here. Well, what is the coordinates of that point? It's 1, 2, 3. 1, 2, 3, 4. So 3, comma, negative 4. The solution to this system is 3, comma, negative 4. Alright, so I've graphed them. So how do I check whether or not my solution is accurate? How do I know or verify that my answer I'm graphing these, how do I know that I've graphed them right or anything else? Well, I can plug and chug that point into my first equation. So going back to here, I would look at this first equation. I'm going to plug these points in. That's my x, and that's my y value. I'm going to plug those in and check to see if it works. Well, two things are going to happen. It's either going to work, I'm going to be happy, it's going to verify, it's going to be that question mark, and I'm going to get a yes, or it's not. If it does, I'm going to plug it into equation 2. If it doesn't work, then it's not the right solution. It's not the solution to the system. And if I plug it into number 2, so let's say I plug in 3 comma negative 4 into here. Negative 3 times 3 is negative 9. Plus 5 is negative 4. Does negative 4 equal negative 4? Yes. So it works. Well, then I plug it into the second one. Does it work or does it not work? Well, if it works, then yes, I have a solution. So 2 yeses, solution. If I get a no, then it's not a solution. Either one of these can be no, and it will not be a solution. Excuse me. So all it needs to do is not work for one equation for it not to be a solution. So going back here, just to verify, let's check in it. So the first equation was y equals negative 3x plus 5. I want to plug in those values. So does negative 4 equal negative 3 times 3 plus 5? That's a question. So I'm plugging and chugging into the first one. Negative 4 equals negative 4, so I'm happy. So now I plug it into the second equation. So right here. So y equals, so negative 4 equals 3 minus 7. And that's a question. That's negative 4. So does negative 4 equal negative 4? Yes. So I have 2 yeses, so I have the correct solution. So it says algebraically determine whether the ordered pair is a solution. So we want to check whether or not 5 comma 2 is a solution or not. So what am I going to do? Well, I'm just going to plug and chug into the first one. So I have my x and my y value and see if it works, and then do the same in the second one. Kind of follow this flow chart that I have here and see. So let's plug it into the first one and see what happens. So I have negative x, which is 5, plus 2 times 2. Does that equal negative 1? Well, negative 5 plus 4 equals negative 1. Negative 5 plus 4 is negative 1. Does negative 1 equal negative 1? So I'm happy. So let's try the second one. So I have x, so 5 equals 3 times y, which is 2, minus 1. That's a question. Does 5 equal 6 minus 1? So is this ordered pair a solution? The answer is yes. I have 2 verified answers here, so it is a solution. So I want to determine whether this ordered pair is a solution to the system. So why don't you try this one on your own and check in with me in just a moment. Alright, let's take a look. So I have my x and my y value here. I'm going to plug these into the first one and see what happens. So I have 3 times 1 plus 2 times 3. And I want to know, does that equal 9? Well, 3 plus 6, does that equal 9? 9 equals 9. So I'm happy after the first one. Let's see what happens on the second equation. So I have negative times 1 plus 3 times 3. And I want to know, does that equal 8? Well, negative 1 plus 9, does that equal 8? And 8 equals 8, so do I have a solution? Yes, I have a solution. So that is the solution to this system of equations. So, in conclusion, the solution to a system is, on a graph, the point of intersection on the graph. And when graph systems can be parallel, they can be coincident, they can be intersecting, and they can be perpendicular. That is the end of today's lesson. If you could please make sure to watch any of the remaining videos and be in contact with your teacher regarding any questions regarding this lesson prior to completing the homework quiz. Make sure that you do your homework assignment as well. And thank you for your time.